In this video, we will learn about the measurement of atmospheric pressure. Now, to measure the value of atmospheric pressure at a place, we use a device called barometer. Thus, a barometer is an instrument or a device used to measure the atmospheric pressure. Now, a simple mercury barometer was designed by Torricelli in 1643. Now, later on, 14's barometer and aneroid's barometer were devised, which are commonly used nowadays. Now, let us study about the simple barometer. So, to design a simple barometer, we take a glass of uniform and wide bore about 1 meter long, or I can say 100 centimeter long, which is closed at one end, and the tube is carefully filled with pure mercury up to the brim so that no air or air bubbles are left in the tube. Now we close the open end of the mercury filled tube by tightly pressing with our thumb, and we quickly invert the tube over a trough partially filled with mercury. Okay. Now when the inverted tube is well immersed into the mercury in the trough, we remove our thumb from the open end of the tube. On removing the thumb, some mercury from the tube falls into the trough, but a height AB, that is this height, as you can see, of the mercury column even now remains in the equilibrium in the tube above the mercury level AC in the trough. Now the space in the tube above the mercury column, that is this space, is completely empty and is known as Torricellian vacuum. As shown in figure B, when mercury level in the tube becomes steady, the pressure inside the tube at point C, that is this point, which is at the same level as that of point A on the free surface of the mercury in the trough, is exactly equal to the atmospheric pressure acting at a point A. Now, as the pressure at point C is equal to the pressure due to the mercury column of height h, that is equal to AB, we can easily conclude that the vertical height of the mercury column from the mercury surface in the trough to the mercury level in the tube is the measure of atmospheric pressure. Now here the height AB, that is equal to h, of the mercury column is usually referred to as the barometric height. We know that atmospheric pressure is equal to h rho g, where rho is the density of the mercury, g is the acceleration due to gravity at that particular place. So at sea level in normal conditions, the barometric height is 76 centimeters. Okay, as the density of mercury is 13.6 into 10 raised to the power 3 kilogram per meter cube, and g is equal to 9.8 meter per second square. The normal atmospheric pressure at sea level would be equal to rho gh, that is 13.6 into 10 raised to the power 3 into 9.8 into 76 centimeters, that will be equal to 1.013 into 10 raised to the power 5 pascals. So the barometric height at a place changes only when the atmospheric pressure at that place changes. Now, it must be carefully noted that the barometric height does not depend upon the shape and the diameter of the tube or on the length of the tube immersed in the mercury in the trough. Moreover, the barometric height remains unchanged even when the tube is tilted as shown in the figure. Okay, so this is the vertical height of the mercury in the barometric tube. Now you can see in this particular picture that the vertical height remains same. Okay, even if the tube is tilted a little bit or more than a little bit, the height or the vertical height remains same. So by this I can easily conclude that the barometric height does not depend upon the size and shape or the diameter of the tube or on the length of the tube immersed in the mercury. I hope this topic is clear to you. Thank you.